Can you hear me now? Am I audible? Please respond in a chat box. Okay. So we will be starting the presentation now. So actually here some power problem was there. That's why we got lost contact. Okay, I think my screen is visible to you people now. So we will start with the unit 3 chapter today. So what is the topic of your unit 3 is nothing but about your conducting materials. Okay. So before starting conducting materials, we should recall what we know from our from your school time, what you know, that we will be first discussing, then we will start with the conducting material. Okay. So previously in school or in intermediate, what we learn about conducting material. So when it comes to your electrical properties, there is some specific properties we know. For example, the specific properties like conductivity. Okay. Similarly, we know about resistivity. Similarly, we also know about your some properties like your electrum or other electrical properties are also there that we will be going to learn later. Okay, for as of now, these are the very two common properties we know from our school days, right? So conductivity means what? When current flows in a material, that material is called as your conducting material, and the property due to which the material is able to conduct the current or let the current pass through it, that is called as your conducting material, and that property is called as your conductivity property. Similarly, when we are considering so what I was saying is that when the material let the current pass through it, then that is called as your conductivity. Due to which property it is letting the current pass through it, that is called as your conductivity. Similarly, when the material don't let the current pass through it, it will be resisting that one. Resisting means what? We are opposing something, right? That is called as your resisting. Okay. So similarly here what happens when a material don't let the current pass through it. When I am saying current passing through any material means what happen? This is indirectly representing that, sorry, this is directly representing that here free electrons are moving inside the material so that the current will pass through it. Okay. So when this particular thing is resisted by a particular material, that is called as your, that property is called as your resistivity. Okay. So if a material is a having good conductivity, then it will be having the poor resistivity. Similarly, if a material is having good resistivity, then it will be having the poor conductivity. Okay. So these two properties are reciprocal to each other. Okay, these are the opposite to each other. So they are interlinked through that point, that if one property is high, then the other property will be having to be lower. Similarly, if this property is high, then the conductivity property should be low. So this is what is the exact concept of your conducting material. Now we know that we learn that a material, if it let the current pass through it, it is called as a conducting material or conductor. If the current is not passing through the material, then it is called as a non-conductor. Okay, but what is the concept behind it? Why these things are happening in material? What is the difference in the atomic structure is there, and what are the different applications we are having? About those things we are going to learn in this chapter. Okay, so first we will see what is a conducting material. As I already told you, conducting material is that material which is allowing the current pass through it easily. Okay, so the material which allow current pass through them easily called the conducting material. Example of conducting materials are like copper, aluminum, and silver, gold. Okay, all kind of metals. Those are metals. We call it as a good conductor of electricity. Why we are saying that a metal is a good conductor of electricity? Because these metals are having free electrons, which will be letting the current pass through it. Okay, this okay, current pass through it. So this property, this particular property of material conductivity for metals, that is going to vary depending upon the number availability, or depending upon the number of free electrons available in the electron cloud. Okay, that is what is your conductor material. Examples, as I told you, all kind of metals if you can consider, they all are the good conductor of electricity. Okay, like copper, silver, aluminum, gold, all these are your good conductor of electricity, and these are called as your conducting material. Okay, and these materials are going to conduct the electricity with high temperature. Okay, so they can withstand this high temperature, and they should let the current pass through them with minimum loss. Okay, minimum power loss. So whenever like you like as we know in our day to day life, if you see, whenever we are going to buy something from market, anything whatever we are doing, what is our target is what? Our target is to um, less expenditure, and gain from there will be more. So what we are focusing on is the value. Okay, value. So what happened here? So whenever we are going to buy any kind of material or whatever you are buying from market, you see that the value should be intact over there. That means if you are paying 5 rupees for some material, then you should be getting that much amount of that much of service from that particular material, from that material. That is what is your value. Similarly, whenever we are going to do any kind of utilization of material, our main target will be economic. Okay, when I am saying economic, what do you understand by economic? Remember this one. Okay, when I am saying economic means what? Economic means, we can say here, you it is not only related to cost. Okay, it is not at all related to cost. To which it is related? It is related to value. Okay, value means what? Here what happens in value? We can, there are example I am going to give you here. Like in market we are having different mobile phones, right? Like for example, consider we are having carbon phone, and we are having Samsung, right? So which one is costlier? Samsung is costlier, right? So the features what we get in Samsung at rupees 25k, the same feature we might be getting in carbon with 10k. Okay, so you see the difference in the price, that this is 10k and this is 25k. Still, what we are doing, if you are getting same feature in carbon phone with 10k, and the same feature you will get in Samsung, you are going to buy this one, not this one. Why? Because you know that this is a reliable product, and this is going to give the value for your product, or value for the money. If you are paying 25k for this particular phone, then you are having that assurance that you will be using this one for 3 years without any problem. But when we are if any problem happens also, then you will be going to get a Free servicing. Wait for 5 minutes. There is some work is going on. I am resuming the class in within 5 minutes. Okay, so I was telling you about this. Okay. So what I was telling you about this value, right? So when I am saying that whenever we are working on an economic thing, then what we can say is that we are, rather than we are seeing how much money we are paying for anything, we would. So when I'm saying economic means what we are looking at it is a value. If you are paying some amount of money for this for anything, then what you are seeing, that you are seeing that for that much of money, how much service you can get from that product. Okay, how many times you can, how much time you can use it, what is its lifetime for using that one. Okay, that is what is the value. So depending of the on the value, we are going to decide whether the product is economic product or not. Okay, so like for example, let us consider, if I same thing I will compare with your Apple phones, right? No doubt this is a good brand. Still, what happen is price is more. Like let us consider 84K phone we are using. So by paying 84K, you bought one phone, but after 3 months or after use of 1 year, you are going to get a better version of that same phone at the same price, right? So that is not that much economic. So what you can do is that you are supposed to use the process where your use a material which is going to give us the uh, desired work they will be giving us. And on the same time, at the same time, we are not supposed to going to invest the money, or or use the money in a what you can say is a more as it required, more than as it required. Okay, so that is what it is showing here. So what happens here when I am saying the when we will use the same concept here, we can see that we need to use a material which is supposed to be working under this high temperature. Okay, why I am saying high temperature means whenever the power is, or whenever we are saying that electricity is passing through a material, at that time what happens, heat is generated in the material. Why heat will be generated? Because that electron that is moving inside the material, that is moving because of the energy transfer. Okay, so always remember, if there is a work is going to be done, then there should be some kind of a energy utilization is there. So what happens here, here your electrons are having their energy. Okay, free energy they are having, as well as they are having the energy due to the spin, right? That energy is going to be transferred, so that that electrons are moving in the in the body, they are receiving the energy, and then they are transferring that energy. That energy we are calling is at your current. Okay, that current is flowing, we are saying. So that energy, that electron, when they are moving inside the body by transferring the energy, they are creating the heat in the material. Okay, sometimes that heat amount of heat is very high. That's why what happened, we are saying that this material should be able to withstand the high temperature. If it is not able to withstand the high temperature, then what will happen, there might be the cause of accident will be there, right? At the same time, when they are that temperature which is generated due to the transfer of the electron, that is nothing but a type of your power loss. Okay, so there should be minimum power loss should be there. Okay, if more power is lost, like for example, when we are transferring the power, let us consider we are transferring 1 kilowatt power, out of that 50 watt is only lost in your transmission. then that is not economic. Okay, that this amount should be very less, the loss should be very less. If more loss is there, then that is not called as your economic, right? That is what is going to be showing, that is what is explained over here. Okay, that this is the most important property if we will see in the point of view of your electrical application, and this is the most important property we are having in the material, and this conductivity, and this conductivity we are expecting in the material for the higher temperature. Okay, at the high temperatures this would be good conductor of heat and electricity. That is what is the good, that is the what is the property, most important property we find in case of our conducting materials. Now silver is the material which is having highest amount of your conductivity. Okay, among the metals, if I consider all the metals, then silver is going to have the highest conductivity of the conductivity. But still we cannot use silver because of its high price. Okay, so if we want to want to use a good conductor that is that is coming in your some little bit less prices compared to silver, then copper is the best material we can use, because this copper falls in the same period, same group of your periodic table, same group of periodic table, also they are having good atomic structures. So because of that, what happened, the silver and copper are having good conductivity. Silver is having highest conductivity, copper is having less than silver, but it is also having good conductivity or conductivity of electricity, right? But again, there is a problem with the copper. Even though silver is having good conductivity, the silver price is very high. Similarly, i- a- after silver, copper is having good conductivity, but the availability of copper in our environment is not that much good. That means the material, the copper or the ore, metals what we are getting, we are extracting them from the ore, and the ore are available in your mines, that is the earth's crust, right? So the copper what we are getting from nature, that is not in a good amount. Okay, the amount is very less. We can get copper very less amount of copper from the environment. That's why it is again difficulty, because material is not available in a heavy amount, then how can we use it in every place? So for to overcome that one, we need to see which is the material available in the earth very highest amount, as well as it should be a good conductor of electricity, even though it is not going to match the conductivity of the material or conductivity of the silver and the copper. So what is the next available material we are having is your aluminum. So aluminum is the highest amount of aluminum is available on earth's crust. Okay, and as well as it is having good conductivity of electricity, even though it is not more than silver or copper. If we can see, then gold is also having the good conductivity property, at least above more than aluminum. Okay, so your high silver is having highest conductivity, then copper is having highest conductivity. But for these two materials, the availability of material as well as the price is more. That's why we are not able to use it everywhere. Okay, in our day to day life, in every place we cannot use it, so we are having specific applications for these two type of material as a conductor. But if we can see silver, say aluminum is also having good conductivity of electricity, but less than gold. Okay, gold is having less than copper and silver, and aluminum is having less than gold. Still, we are not using gold because, as we know, it is going to be very expensive as compared to silver. Gold is going to be more expensive if we can, if we will see that one. That's why we are not going to use gold and silver. Gold, we are not using gold as a conductor. Silver is having very little application. Copper and aluminum are the two materials which are having very wide range of application as a conductor in electrical application. Other than this, we are having other metals like arsenic, tin, bismuth. Okay, these metals are not able to. These metals are having very complex structure. Okay, due to that, what happened? Their conductivity is not going to be falling under falling is at the level of your conductors, neither their conductivity is falling is the level of your insulator. It is somewhere in between. Still we cannot use them because of their less conductivity property as well as because of their complex structure. Okay, do you have any doubt in this one? Do you have any doubt in this one? Raise your hand if you have any doubt. Otherwise, I will start the next topic, next slide. So no doubt we should be moving to the next slide. Okay. So what is it saying? Resistivity or conductivity? As I already told you, resistivity and conductivity are reciprocal to each other. That's why what happened here, the the resist we can uh, classify a material basing upon its conductivity. Also we can classify it basing upon our resistivity of the material. So now you see here resistivity and conductivity of material, what it is saying? It is saying that electrical resistivity is also called as your specific resistance. Okay, this is the intrinsic property of the material. Intrinsic property means what? Intrinsic property means it is the property which is naturally available with the material. Okay, we are not going to we are not influencing that property. Okay, that is what is the natural availability of the property, that is your intrinsic property of the material. Similarly, conductivity is also a intrinsic property of the material. If a material is having low resistivity, then it is a conductor, good conductor of electricity. If a material is having high resistance, then it is called as a bad conductor of electricity. In some cases, we call it as a insulator. And the common representation of resistivity is rho, and we are its unit is ohm meter. Okay, the common representation of resistance is rho, which is having the unit of ohm meter. Okay, similarly, common representation of conductivity is K, or we are also representing as G, and it is having this is what is the this is what is the representation of your unit of the K, that is your ohm meter power to the minus 1. Why? Because your resistivity is reciprocal of conductivity, or conductivity is reciprocal of resistivity. If resistivity is having unit ohm meter, then your conductivity is going to have the unit of ohm meter to the power minus 1, or we can say 1 by ohm meter. Okay, for example, if you can see that a material which is having 1 meter, a material of a cube of 1 unit length. Okay, here meter is taken, 1 unit length I am saying, 1 meter and 1 meter and 1 meter cube is there. Then the resistance, the material has seat contact on two opposite faces. Okay, so if a material like consider this particular material is having 1 ohm of the resistivity, then the conductivity will be, okay, so let it be. No, don't go for this complex thing. We will directly go to the next topic. Okay, so here what we can say that this is your resistivity. So this is what is your resistance. Okay, resistance of a material is equal to, I can say resistance of a material is equal to rho L by A, where L is the length of the material. Let us consider we are having a wire over here. Then this is the length of the material L. And what is its area? Area means if this is a wire. Okay, so let us consider, I am considering this is a wire, I am considering this wire is a conductor. For this one I am calculating the resistance. Then this is the length of the wire, and if I see from this side, like from this side if I see, then what I can see? I can see a circular one. Circular cross section. This is called as your cross section. This is this H portion what I shown here, that is your cross sectional area A. So I can say that here resistance is equal to rho L by A, where R, rho is equal to resistivity of the material, L is the length of the wire, A is the cross sectional area of the wire. If from resistance we are calculating conductance, then K is equal to 1 by rho. Okay, that is what is your conductivity of the material. So when we are seeing this one, when we are saying that a material is a conducting material or it is having this much amount of conductivity, then depending upon this conductivity, we are having three types of material. Name termed is conductor, okay, insulator, and semiconductor. And now in newly we can add another term, superconductor. About superconductor, as I told you, this super we are having superconductor in our in the end of during around the end of the chapter. So as of now we will be knowing these three. At the end we will be learning the superconductor. What is a conductor? Conductor is there already, you know. Conductor is that one which is going to let the current pass through it. It is a conductor. It is insulator means a material which doesn't let the electricity pass through it, that is an insulator. What is a semiconductor then? Semiconductor is that material which is having both conductivity property and resistivity property. But the thing is that here there is a range of temperature. Let us consider we are having three range of temperature here. Okay, two range of temperature. So up to x degree centigrade, the material, let us consider we are having a temperature of T degree centigrade. Okay, so T degree centigrade, the material up to T degree centigrade will act as a conductor, but after that it will be acting as an insulator, or vice versa. Up to T degree centigrade it might be acting as an insulator, but once it reaches the temperature it will start to act as a conductor again. Those are called as your semiconductor. The example of conductor is what? Like silver, aluminium, copper. Those are the example of semiconductor. Example of insulator, paper, wood, glass. Okay, these rubber. These are the insulator. Similarly, what is the example of silicon semiconductor? These are germanium and silicon, naturally available semiconductor. Remember, this is naturally available semiconductor. We also manufacture it for this. We also manufacture the semiconductor, like your any kind of compound also can be acting as a semiconductor. That is a formulated one. Okay, that is not naturally available. That is a formulated semiconductor. Okay, so here what you can see, if we are having a conductor, that means its resistivity is going to be, sorry, its conductivity is going to be more than 10 to the power 7 ohm meter to the power minus 1. Similarly, if this conductivity range falls between 10 to the power minus 6 to 10 to the power 4, then it will be a semiconductor. And if it is less than 10 to the power minus 10 to the power minus 1 ohm meter to the power minus 1, then it will be act as an insulator. So these things what you can see over here, these are the range of conductivity. Okay, so next class we will be seeing how exactly these conductor, insulator and semiconductors are classified depending on their energy. Okay, so if you have any doubt in today's class, you can ask now. Please put the message in the comment box. Otherwise, raise your hand. I will let you unmute yourself. Yes, Yaswant. 1 minute. So you can unmute yourself now, Yaswant, and you can ask your doubt.
Madam, doubt, madam.
Yeah, yes, ask.
Madam, unlike semiconductors, if we raise the temperature of insulators, can conduction be increased, madam?
For what? Again, tell me.
Insulators.
For semiconductors, what you are asking? Ask again.
Madam, unlike semiconductors, if we increase the temperature of insulators, will they conduct electricity, madam?
No, as they cannot conduct the electricity even if you raise the temperature. That is why they are called as an insulator. Otherwise, they will fall under semiconductor, na?
Even in any situation, madam.
Any situation. They will not be conducting the electricity in any situation.
Okay, madam.
Hmm. Is there any doubt? You people are having, anyone else having doubt? Anyone else have doubt? Please raise your hand, otherwise put the message in comment box. So you people are not having any doubt. So I am ending the class here today.